Hello and welcome to my channel Educate to Grow. Today's session is all about to learn the core concept of least common multiple and highest common factor or the greatest common division. So this is a very important session because I'm going to explain the basic parameters which are very much required to understand and learn. And if you learn those things, definitely you will be able to solve the problem without any issues. Okay, without much delay, we will start in depth this session. And please subscribe, like, and share the content to your friends and the students. Okay, let's begin. So the first one is very much required to understand, that is factors. What do you mean by factor? What do you mean by multiple or a product? Okay, and then we need to understand the prime numbers and prime factorization. Okay, and then later comes a definition that is called LCM, that is the least common multiple, and HCF, that is the highest common factor or the greatest common division. So to solve these two categories of problems, we have a different methodologies which we are going to discuss now. Okay, now let's start with the factors. The factors are nothing but these are the numbers which are responsible to generate a product, responsible to generate a multiple number. Let me take one example. One number is 3 and 5. Okay, I'm going to do the multiplication and we get a number 15. This 15 is the product of, product of 3 and 5. Without these 2, 3 and 5, we won't get 15 by product. So this is called product. Okay, and another word called multiple. This is very important to understand. So what are those 3 and 5? Those 3 or 5 are responsible to generate this 15. So hence this is called factor. This is factor 1 and this is factor 2. So this is the concept of factor and multiple. Let's get into the next section where we will be understanding the prime and the prime factors. Okay, let me explain you about the prime numbers in a simple way. First, it is a number. Okay, it has only the 2 factors only. So first it is a number. Okay, the second condition, it has only 2 factors only, and in that one factor is always number itself. And fourth point is another factor is always 1. Another important point here is this is always greater than 1. Any condition which satisfies these points, those are prime numbers. Let me tell you one example. So take number 2, which is greater than 1, agree. So it has the factors are 2 into 1. You see, it has only 2 factors, agree. One factor is number itself, agree. And another factor is always 1. And it is a greater than 1. That's it. For example, if you take another number, that is a 3 equals to 3 into 1. Why not the number 4? I'll tell you, explain it. 4 equals to 2 into 2. It is a number, agree. And 2 factors, agree. One factor is number itself, that is failed here. That is failed. This is not number. this number is not this one, it is failed, and another number is 1, that is also failed, and it is greater than 1, agree, but the conditions are not satisfied, hence the 4 is not a prime number. So this is about the prime. Let me explain now the prime factor. So what is prime factor? Take any number, for example 24. That number is multiple all the time of different factors. This number, we have to use prime numbers to divide it to get the remainder 0. So how many times we use the prime numbers? Those are the factors of the prime. Let me take you one example here. This is 24. I'm going to use the first start with a 2, that is a prime number, and 2 into 12. These are the two factors, agree. Then we have to use 2 into 6, two factors. Then we have to use 2 into 3. So how many 2 are there here? 3 times 2 and 3. But the common one is only 2 and 3. These are called the prime factors of 24. Understood? These are called prime factors. The simple way I would say that any multiple number that is divisible by prime number, then that is called prime factors. Okay, let's continue with the next option, that is the least common, and the HCF and GCD we will start one by one. Let me explain the least common multiple, that is LCM. I'm going to make you understand what you mean by least, what you mean by common, what you mean by multiple. The first condition here is we need minimum 2 numbers, then only we need to solve this problem. I'll make you justify this statement, why we need 2 numbers or more than 2 numbers. Just let me take one example at this moment. Take a number 4 and number 6. Now we need to find the multiples of these 2 numbers, that is the multiples. We are going to calculate now multiples. Let's write the multiples. So these are the 2 numbers and multiples. Let's find the common. The second step is finding the common. 4, 6, 8, 12, 8, 12 and 12, 18. So we have a 12 number. This is the first common number. Next 16, 18, 20, 24, 24. Yeah, 24 is there here, second common. Irrespective of the position, we need to find the common number. Second, then 30, 28, 36, 20, 36, 32 and 42. Okay, 42, 36. So we have a 36, another common number. This is third. Okay, now that's it. Let's stop here. We will get a n number of common numbers from this multiple range, because the numbers which goes here is the infinity number level. Okay, so let me list those common numbers. We have a 12, we have a 24, we have a 36. Agree? We need to find now the least number from this common list, that is this one. This is the minimum number, this is the least number, and this is the first occurrence from the list of common. So answer is now this is 12. So this method is called list of multiples. This is the one of the method to find the LCM. And also we have another 2 methods. Let me tell you those things. Second one is a prime factorization method, In that we are going to use only the prime numbers, and how to find those I'm going to explain taking the same examples. Then third one is division method, taking the same example how to divide the numbers and get the LCM number. So the first method always it's easy, but it takes a time. It's a time consuming. You're not able to find in a shorter time. If you given a number, bigger number, it's quite difficult. That's why we need to get into the second method, prime factorization or division method, to solve. Also in the exam, you will be asked to find the LCM using the factor method, using the list of multiplies method, or using the division method. So you should be aware about all these three methods properly. Let's check out the second method, that is prime factorization method. The first method is time consuming, and if you given a larger number, it is difficult to find the multiples and find the common one. So in this case, the prime factorization helps a lot. Let me take two numbers and explain you how to solve it using the prime factorization. Before that, we have some conditions we need to concentrate, we need to satisfy those conditions. So what are those conditions? Let's look into it. First, the numbers are, I'm going to take 24 and 15. Find the LCM for this. So these are the two numbers. First condition is given numbers are multiple numbers. We need to consider those numbers as a multiple numbers. First point. Let's get into the second one. Second one is we need to expand the multiple into the prime factors. Let's see how to do it. Let's take a 24 first. 24 is 2 into 12. So 12 becomes a 2 into 6. 6 becomes a 2 into 3. So we have a 2, 2, 2 and 3. So now we need to find the 15. So 15 is 3 into 5. So this is how we expanded the prime numbers. Let me take a third point which we need to concentrate, that is identify the prime numbers. So identify the prime numbers 2, 3 and 5 in this. Okay, now fourth point is group the highest exponent. For 2 we have 3 factors. So 2 to the power 3 equals to 8. Now for 3 we have a 1 here, we have a 1 here, highest is a 1, so this is a 3 only. So for 5 we have a 5, 1, there is no 5 here, so only 5, so 1. So now fifth point is we need to multiply these numbers. Okay, 8, 3 into 5 equals to 120. So this is how we need to find the LCM for the given numbers. So if you go with the previous method, I'm going to tell you just to try with that option. Do the multiplication numbers of 24, do the 15 multiplication numbers and find the common. You will end up with the 120. Okay, but it is a time consuming, but this is the easiest method because of the prime factorization. So let's get into the next method, that is called division method. Now let us concentrate the third method, which is division method. How to find the LCM using the division method, that is the question. So, or you may get the question like solve the problem using the division method. Here the division method is very simple. We need to use a prime number to divide the given numbers. Make sure you get the remainder 0. So that's the one method. So let's start with the example. We have a number 12 and we have a 15. So let's start with this one. So we need to use this like this, and we need to start first prime number 2, and 2 into 6 it's a 12, so we have to do, you will get the 0, so that is the one. And 15 we cannot divide 15, so any number which is not able to divide from the prime number, then keep it as it is same. Now let us continue the same concept till we get 1 quotient. So 2 to 3 and 15, and now we have a 3, 1 and 5, and then we have to use 5, 1 and 1. So this is how it is. Now we have to use these things: 2 into 2 into 3 into 5. So once again 4 plus into 3 into 5, so 12 into 60. So this is the answer. Let us check the other example. Let's find the 24 and 15. So we will check it out. This one starts with the 2 prime and 12 and 15 remains same. Next 2, 6, once again 15 remains same. Now once again 2, 3, 15. Now 3, 1, 5. So 5, 1, 1. So this is the 3. 2 to 4, 4 to 2, 8, 8 into 3, 24, 24 into 5 is 120. So this is the answer. So this is the simple method which we are going to use for the dividend method. So this is the least common multiple method. So that's it all about the LCM. We are going to study about HCF now, or a GCD in the next section. Okay, now let us find the HCF, how to calculate and what are the methods. See, now we have only 2 methods in the HCF. One is prime factorization method and as well as the division method. Let's look into the prime factorization method. In the prime factorization method, we have still undergo a few conditions. So what are those conditions? First condition is always minimum 2 numbers or more than 2 numbers is always required. Second point is the given number is always a multiple number. Okay, we need to find the common factor which is highest common factor. Okay, that is the HCF. Now third point is the given factor we need to expand into the prime factors. Okay, so just like what we did in the LCM. Now the next point is we need to group. Okay, we need to find the common prime number from the expanded one with respect to other number as well, other expanded number as well. So ultimately we need to find the common prime number. The next point here is we need to find what is the least exponent number in that of that common number. We need to take that point as well. Then we need to multiply together the common number with the least exponent, that the result will get the highest common factor, or it is also called greatest common factor. Why the factor here is because we are finding a number which is responsible to generate a same product of these 2 numbers or 3 numbers, whatever the given numbers. And if we divide also, it will divide all the given numbers. So that is the concept here. Let's look into the example. First, let me take an example here. Take 4 and 6. Okay, the 4 factors 2 into 2. Okay, this is, we are expanding here into the prime numbers. 6 is a 2 into 3. Now the point here is we need to find the common prime number. What is that common prime number? Here is 2, here is 2. So the common prime number is 2. And also we need to find the least exponent number. Here the least exponent number is what? 2. And here the least exponent is 1 and 3 is 1. So the common prime number is 2 and least exponent number is 1. So here only 1. The answer is 2. That's it, because there is no multiplication point of view, there is no other number multiplication purpose. Find another number, 24 and 15. Okay, let's get into the expanded. This is called a multiple number. This is called multiple, this is called multiple. Okay, now let's expand it first. So let's expand 2 into 12, 2 into 6, 3 into 2, or 2 into 3, whatever. So we get 2 into 2 into 2 into 3. So if we do exponent power, 2 to the power of 3 and 3. Let's do the for this 3 into 5 for a 15. So here we get exponent 1 and here exponent get 5. Find the from here and from here what is the common prime number. The prime number is 3, because 2 is not there in this, 3 is there, and let's take a 3. Okay, find the least exponent number of that 3. Only 1 is there, that is a 1. This is the answer. So this is the how to calculate the highest factor, common factor, okay, or the greatest common factor. Let's take another example. Now let's take example 3 numbers. For example, let's take 3 numbers, 120, okay, and 320 and 420. Now let's find out. Here 2 into 60, 2 into 30, and 2 into 15, and 3 into 5. So let's find out how much 2 to the power of 3, 1, 2, 3 into 3 into 5. So this is only exponent 1. Let's make into 320. Here 2 into, this is 160, this is 2 into 80, so 2 into 40, so this is 2 into 20, so this is 2 into 10, this is 2 into 5. How many things? 2, 3, 4, 5, 6. So here is a 2 to the power 6 and 5, 1. Okay, now let's get into the 420. So 2 into 2, 210. This 2 into 105, 3. So 3 into 35. So this 35 is 5. I think 3 is not possible, so I have to go with 5 into 7. So let's find out here. 1, 2, 2 to the power of 2 into 3 equals to 1 to the power and into 5 and 7. So let's find out here. Minimum here is 2. Common factors, how many are there? From here, from here, from here. The common are only 2. Okay, another one is 3 is here. No 3, no, only 3 here. So only 5 is there. So pick the 5. Now let's find the common number, common least number. This is 3 here, this is 6, this is, and this is 2. So what is the least out of these 2? So least is 2. Okay, now 5 is 1, so multiply it here. 2 to the power of 2, 4 into 5 equals to 20. Answer is 20. So it means 20 is the highest common factor which will be used to divide this number and this number and this number. We get equally. That's how we are going to calculate the HCF using the prime factorization. This is the method. Let's get into the another method called division method, and also another word called Euclid methodology. This is a bit different than what we found in the LCM. Okay, let's get into that method. In the division method, still we have condition. What is that condition? Here is also the minimum 2, and given more than 2 number, we can use the division method. That is the point. The second point here is we need to pick only the first 2 numbers. If the numbers are given only 2, then you need to pick only those 2. If the numbers are given 3 combinations, then we need to pick first two, and whatever we get the result, that one we need to club with the third number and do the same calculation once again. So that's let me show you that one once again in the example. So that is a point. So we need to pick first only two. Okay, then we need to find out of those two what is the least number in that. So we need to use that number to divide the largest number. So divide the largest number by smallest number, and in that we get a remainder. Okay, that remainder becomes a division number, and whatever the previously we divided, whatever previously we used for the division, that number becomes a dividend. I'll show you how exactly, and then continue the process till we get a remainder 0. So the which number is responsible as a divisor to make a remainder 0, that is the answer here. So let me explain you here. Let me take directly the three number, same number, 120 and 320 and 420. So this is the three numbers. The condition says we have to use first only the two numbers, pick only two numbers, these two numbers, 120 and 320, and we need to find the least number or the smallest number out of these two numbers. The least number is 120. So let's do the, this becomes a divisor and this becomes a dividend. So how exactly dividend means 320 will be here and 120 here. 122s are 240 and we get 80. Okay, and this is nothing called a remainder. Okay, and this is called a quotient. Now we need to use this 80. So let me do the once again, this 80 and use this 120 becomes a dividend. Okay, now we have to do once again calculation, same procedure, 80 into 180 and we get a 40. This is a remainder. Okay, now this remainder becomes a divisor and this 80 becomes a dividend. So let's do it, 40 into 2, 80, so 0. So this is the responsible number which made into remainder 0. So let's pick this 40 now, 40 now 420. So we need to combine with the third number, then we need to find the least number here. This is the least number, so this becomes a divisor and this becomes a dividend. So 420 and 40. So let's do it, 40 into 10 equal to 400, or 40 10 ja 400. So let's do it, and the remainder is 20. So this remainder becomes a divisor, and once again I told this 40 will be here. Okay, and do once again calculation, 20 to the how much, 40. So here you see here 20 is the responsible, 20 is the number which made the combination of numbers into the 0 all at the last till the last position. So this becomes the answer here, this becomes the answer. So that's why we need to find this is the method called division, and this is also called Euclid method. So this is as simple as that. So this is all about highest common factor or the greatest common division. So far you studied all the things with respect to LCM and HCF or GCD. I request you to like and hit the button subscribe and share the content to the friends and students. I also request you to join to my social media network, Facebook and Instagram, Educate to Grow. In the Telegram we have a group where I already uploaded all the videos of this one into the Educate to Grow group, and then in the YouTube if you search Educated to Grow you'll get a channel, and get into the channel you'll find a lot of study material like this. Okay, request you to join and share it. Thank you very much. Let's see into the next content.